So just to kind of get us started and get back into things, my name's Jason, and this is Eric, who's kind of with me, helped me set this up today. We're both committers on the Solr project, and we're both kind of interested in helping new contributors get started and get involved in the code base. It's been kind of a great experience for me, and something we just want to see others be able to get into. So just for a little context, this is the second in a series of workshops on contributing to Solr. The first workshop was kind of on the general contribution process and what the community is like. So we're shifting to a pretty different topic today. So there was a question before we started about, do you have to watch the first workshop? It's probably beneficial, but I don't think they're not really too interrelated. It should be fine if you're only coming to this one. Because we're kind of having such a huge, I guess, shift in topic, I wanted to kind of discuss why that is a little bit and hope it makes sense for you guys. But as people come to Solr and they're looking to contribute, we thought it might make sense to pick a specific area of the code that people could focus on. And then that way, there's less to learn, it's less overwhelming at the start, and they can kind of get a deep dive on one particular area that they can feel confident contributing to. And so in particular, we picked the APIs, the V1 and the V2 APIs in Solr for a couple of reasons. The first reason is that when you're working with APIs, there's kind of this nice effort to impact trade-off or ratio, where even a small change in terms of complexity or lines of code can really have kind of an outsized impact on the users of the project, because you're making something more intuitive for them, you're making something easier for them. So that's going to impact them right away. The second reason we chose the Solr APIs is because there's a lot of work going on in that area that Eric and I are both kind of involved in. So we know it well, it's easy to present on. And since it's active, there's people there to review your code. There's new dev tickets that are there to be picked up. There's people to ask questions to, all that kind of stuff. So when you're getting started, it's really important to have an active area of development to get into. Were you saying something there, Eric?
Nope, just nodding vigorously.
Okay, excellent. Cool. So that's why we're talking about APIs today, even though it's kind of pretty different from our first week's topic. In terms of how we're going to cover things, I've already kind of given a little bit of the motivation for this talk. From here, we'll get into kind of the state of the union in terms of APIs and Solr. We have a couple different API frameworks and versions that we use. So we'll talk about the V1 APIs and what those look like today. Then we'll move on to the V2 APIs and talk about what they look like today. From there, once we've kind of laid that foundation of where things are today, we'll talk about some of the things that are going on in terms of what changes the community is trying to make around these APIs, what directions we're trying to move in. And hopefully that'll inspire some places that you guys might want to get involved in. Lastly, kind of is a concrete example of some of these changes that are going on right now. I was thinking we could walk through kind of a live pseudo coding exercise to take one of these APIs that we're trying to improve and just kind of walk through in the IDE what kind of those changes are going to look like. And hopefully that'll make things a little more concrete for folks. Any questions before I get rolling here? Cool. Okay. So first, like I said, we're going to talk about kind of where the APIs are today, and we're going to start with V1. And if you want to understand Solr's V1 API, the key place to go is to this request handler abstraction. This is a Java class. Actually, let me pull up my IDE here and we can try to look at it. Request handler base. Is the text size on this IDE okay for everybody? Is this readable? I can go up one more. If anybody has trouble reading as I'm going through, just give me a shout. So this is a class called request handler base, and this is kind of the parent class of all APIs in Solr. All of the V1 APIs, that is. But the request handler is, you can kind of think of it as being synonymous with an API, except that request handlers are integrated with a lot of other kind of pieces of the Solr puzzle. They're integrated with metrics. Metrics kind of go through request handlers to get reported. They're integrated with authorization. Solr has this authorization framework that it can use if you choose to. So there's a lot of responsibilities the request handler has. A lot of these kind of on an API to API basis are kind of handled up in one of these parent classes. So you don't tend to have to think about it all that much, but they are there. In terms of kind of the key place to get started, if you're looking at a particular request handler, the main place that you're going to want to pay attention to is this method handle request body. This is kind of the entry point. You send an HTTP request to Solr. It goes through Jetty and some pre-processing. And ultimately, it's going to end up in one of these handle request body methods. And there's a Solr query request and a Solr query response. Those are kind of how you get your inputs and outputs for the API. And then you have this method body to do whatever you want to those. So that's kind of the request handler, a very zoomed out view. Let's see. So in terms of how these fit into kind of the larger picture of Solr, there's request handlers that live in several different places. There are request handlers that are kind of associated with the Solr process more broadly. And these are often called Solr admin APIs, though that's kind of a bad name. But the idea is that they're associated with the Solr process and not some particular Solr core. A core in Solr is kind of the atomic wrapper around a single index. So you might have a single collection that results in multiple cores. And the cores themselves have request handlers, like you can search on a core, you can update documents in a core, and these each have different request handlers. So there are core request handlers and there are admin request handlers. And those names aren't great, but hopefully this diagram can make it a little clear. Kind of it's just a matter of where they live or who owns them, the core or the process as a whole. The other thing to note about request handlers is a lot of them, when you start up Solr, they just appear implicitly. You don't have to do anything to get a search endpoint when you create a Solr collection. It's already there. But there's also some customization that Solr offers for this. There's a config file called solrconfig.xml that each collection has. And you can look in there and there's kind of customization options for declaring your own request handlers, either using a class that is maybe new, or if you want to specify some default values for kind of an existing request handler class, you can specify all that in solrconfig.xml. So request handlers can live multiple places. They can either be implicit or they can be customized. There's a kind of a lot going on here in terms of how these are actually executed by Solr. This is mostly just kind of summarizing that. But the one thing that we'll want to look at in a little more detail is some of the downsides with the V1 API framework. And the best way to look at this is to kind of consider this handle request body method signature here. We have this object, which is our inputs, and we have this object, which is our outputs. But what these things actually mean is not really clear. And a better way of putting that is it's not really clear what inputs or what query parameters you should actually expect. If you go to look at what's in this request object, you can call request.get params, and that returns you a Solr params object, but essentially that's a map. There's no indication of what the keys are supposed to be, or whether things are query parameters or whether they're in the request body. There's no indication really what the inputs are supposed to be at all, other than that they're going to be in this map somewhere. And the response is kind of the same way. Solr query response has a method called getValues, which returns a named list, which is an abstraction you see all over Solr. That's it's like a map. It's kind of key value lookup, but there's a notion of ordering to it, so they call it a named list. But this is how Solr represents its response back to users in the V1 framework. So you get this get values, and then essentially the interface you're looking at here is it's a map. There's no indication of what the response for this API should look like, or what values to expect to be here at a certain point in processing. So the V1 API framework is very kind of loosely typed, very implicit in terms of its in terms of its inputs and its outputs, which makes it hard for users to work with. It makes it hard for developers to work with. It can be a problem. Excuse me, just a second. Another downside of the V1 APIs is that as they've been written, is that often a single request handler is used to kind of handle many, many logical APIs. We're looking here at collections handler, which handles, if you're familiar with the /admin/collections API. And this looks like a relatively simple handle request body method. It's 20 lines, 30 lines. But if you look at what's happening, it takes this one parameter that's kind of an enum string value, and it looks up a collection operation, which can be one of 20 or 30 different things. This is, in this request handler is how you create collections. It's how you get the collection status. It's how you delete collections or reload collections or rename collections or do any of these kind of admin-y tasks. They're all shoved into one place. And that's kind of a downside of this V1 framework. That things have kind of grown monolithically. The last thing I want to point out about the V1 framework is that the endpoints themselves and how they're exposed to users in terms of the API paths, in terms of the query parameters that get used, it's a very organic design, which is kind of one way of saying that the APIs kind of grow up individually and there's no thought put to cohesion or how they fit with one another or how they present to the user kind of conceptually, which is totally reasonable for a project run by developers and that develops over decades, but it's still not a great user experience. So these are issues with the V1 framework. So let me go back to our public key handler. This is one of the examples we were looking at before. This is actually the request handler that gets you kind of a public key that an individual Solr node has. Solr nodes have kind of cryptography keys for talking to one another, and there's an endpoint that gets you the public key, and that's what we're looking at here. So to kind of have a point of contrast with this V1 framework, we can jump into the V2 version of this code, which is this public key API class. And it should stand out as different from the request handler in a few different ways. The first way is we have a lot of annotations here. This is an @path annotation, and it looks like that's a URL path there. This is an @get annotation, which if you look it up, this controls kind of the HTTP method used to invoke this API. And these things are all coming from a spec called JAX-RS, which is a public spec that kind of describes the way that Java code can list out or enumerate or describe their APIs. So it's a public spec. There's various libraries that code to it, be they Jersey or Spring or REST-easy or JBoss. There's all kinds of different implementations. Solr just recently has kind of gotten an integration with Jersey. That's the library that we're using to back up these annotations here. And one advantage of doing kind of this JAX-RS method of defining APIs is that your inputs and your outputs are very, very explicit. So you can take a look at this method here, which is kind of similar to the handle request body, and that it's your entry point for running this API. And that there are no arguments to the method. And that might be confusing, but that's because this API doesn't take any parameters. There's no way to change its behavior. If there were parameters, they'd appear here. And actually, we can look at an example. We can look at an example that does have input parameters. So this is the add replica property API that takes in a collection name and a shard name and a replica name. The formatting here is a little ugly with the annotations and the indenting. But you can kind of see that the JAX-RS framework allows you to be really explicit about what your inputs are and where they come from. So say here is a collection name, and it comes from this path parameter called call name. And if you go up and look at the path, you can see that it's going to be the segment right after /collections. So there's very, very explicitly these inputs and outputs are shown. Let's go back to public key API. And the same thing is true with the response. The return value from this method is a public key response, which you can look at, and kind of at a glance, you can see the format that you'd expect here. There's no question about like what properties are in this map, or what kind of things are in here. You can see that, hey, we have a key property, and that's pretty much it. That's where your public key is going to be. It's worth noting, we kind of extend this Solr Jersey response based class, which has the response header you probably see in a lot of Solr APIs. It has a way to report errors. The details of kind of what this request and what this response look like are not the most important thing. The thing to keep in mind is that the V2 API is very explicit about where all your inputs, what they all are and where they come from, and then what the response is supposed to look like as well. So that's a big advantage of the V2 framework. Another advantage is that being a public spec, the JAX-RS APIs are also really easy to integrate with other tooling that's kind of grown up around this ecosystem. And in particular, one that's kind of really promising for Solr and in general, I think, is OpenAPI, which, if you're not familiar with it, the premise of OpenAPI is that it can scan your code, looking for some of these annotations or other things that you've put in to indicate APIs. And it will generate a machine readable JSON or YAML file describing every API in your server. And so once it generates that file, there's other really cool stuff that you can do with it. You can generate web UIs to help people submit API requests. You can generate kind of clients for different languages, just kind of entirely auto-generated based on this one text file. So it's a really powerful thing that is promising as we move more and more APIs to this JAX-RS framework. Any questions about that before I move on? Okay, great. So it's worth mentioning, while we're talking about kind of the state of V2, that the JAX-RS framework we just looked at it's really Solr's kind of second or third attempt at a framework for these V2 APIs. There's actually a very similar framework to JAX-RS. It's based on annotations. It works very similarly, but it was kind of built internal to the project several years ago. And it's functional, it works fine, but it doesn't have a lot of those benefits of JAX-RS that we talked about in terms of the explicit inputs and outputs, the strong typing, the integration with this other tooling. And so if you look at a lot of our V2 APIs today, it's going to be a mix between JAX-RS and this legacy framework. I don't want to dwell too long on this. This is kind of just comparing those two frameworks. They're still there. Yeah, that's all I'll say on them for now. Yeah, so that is kind of the state of our V1 and our V2 APIs. But the community is kind of actively working to change this in a few ways. The big push right now is around V2, both for some of the user benefits and for our own kind of internal maintenance and code quality and those sorts of reasons. So the ultimate goal is to get V2 to a place that we're happy with and where we want it, such that we can go deprecate the V1 API. That work of getting V2 where we want it has a couple of different pieces. So we'll kind of walk through those in more detail, because those are the things that we think make great new dev tickets and where the activity is kind of going on right now. So we'll look at kind of each of these in detail. So one of the first things that's going on with the V2 APIs is we're trying to kind of polish and reshape what they look like in terms of HTTP endpoints. I've included an example here where on the left is the current V2 endpoint for a kind of functionality that's called deleting an alias property. An alias property is a thing that exists and you can delete it. So on the left is the existing V2 format for this API, and on the right is kind of this proposed alternative. So the reason I wanted to show this is that there's nothing wrong with the left-hand version. I think it's pretty clear what it does. If you see set alias property, and if you see, it's setting it to an empty string. So most people would probably get that that means deletion. So it's clear, but it's maybe not intuitive. If you were sitting down to like run a curl command, you probably wouldn't just guess that this was the API. So where we want to get to is a point where our APIs across all of Solr follow enough of a pattern that somebody who's seen a few of them can guess what a particular API would be. So here we're using kind of a much longer, more granular path. We're saying, okay, we're talking about the APIs, and now we're talking about all of our aliases, and not just all aliases, but the specific alias, and not just the alias, but the properties of the alias, and then this specific property name. So it has like a very granular nature, and it gets more specific as you go through the path. And then the HTTP verb that accompanies this is delete. So it tells you kind of what you're doing to that resource, for lack of a better term. And then, oops, didn't mean to jump that. You might not immediately guess this, but if you've seen the delete collection API, and you've seen the delete field API, and you've seen the delete core API, then there should be enough of a pattern established that this is kind of intuitive and something that you can guess without going to the docs and having to look it up. So that's kind of the thing that we're chasing with the V2 API, is to really kind of establish enough cohesion across our APIs to make it something that people feel is more intuitive. There's another example here, but it's probably not worth going through. One of the things I wanted to point out is that we propose these changes, though. A few people in the Solr community have kind of already done the work of describing maybe what the changes should be and what the V2 endpoint should look like. So there's a spreadsheet available, and I've linked to it here from the slides, which I'll publish after this talk. But there's a Google sheet that kind of lays out all of Solr's APIs, the V1 APIs, and then kind of what the current V2 API is, and then what the proposed change to it would be. And so we've discussed this on the Solr mailing list, and this proposal has all kind of gotten the thumbs up from people. So it's not set in stone. It can still change. We're still open to feedback, but is someone starts on some of these tickets that change the API, there's already kind of a thumbs up to that work. And this is that spreadsheet, just in case anybody's curious. There's these lists of APIs, and then there's what the V1 looks like. There's what the V2 looks like, and then there's kind of a proposed change. And then there's some pointers to where stuff lives in the code if you wanted to get started. Cool. Any questions about any of that? All right.
I have a quick question.
Yeah, let's hear it.
Yeah. So is it basically the change here is just taking the endpoint from the version 1 to version 2, or maybe do a bit of cosmetic changes? Is there any need to change the logic, or just the way the API, the people are interacting with the APIs? Are we going to change the underlying logic in that API being exposed in API 1, version 1?
No. So,
okay.
So in this example, right, we're taking kind of an existing V2 API, and we're just changing, like you said, the cosmetics of it, which is a great word. So it's not really changing the underlying API logic. It's not just as simple as, say, kind of editing the annotation in the code to change this path to be something different, because it might start that simple, but then you'll find that some tests fail, and you got to go look at why those tests fail. And, so there's other stuff that this does pull in. But this kind of work itself doesn't involve changing the content of the APIs, just the cosmetics.
Which is great, because it introduces you to the underlying API without touching them. So you get familiarity with it. At the same time, you're improving the whole experience, because, yeah, I mean, the API and knowing what the API can do is a very great thing to know, even the application itself. Okay, yeah.
Cool. And there are, I mean, the next couple of things that we'll talk about here. Let me actually jump into the next slide. So there are aspects of the V2 work that are kind of more digging your hands in and getting involved in the API functionality itself. And this is going to be one of them. So there are a lot of places in the V2 API right now where for whatever reason, there's certain functionality that V1 has or that Solr has in general that's not exposed in our V2 API. This is kind of a historical mistake that's come up, but there's a lot of these APIs that we just need to add some new equivalent to it in V2. And so these, you're going to be kind of touching much more code than if you're just changing the cosmetics alone. And again, kind of looking at this API proposal spreadsheet is a great place to get started for some of this kind of work. So the last big thing for the V2 APIs that's going on right now is we talked about kind of this JAX-RS framework that's the proposed thing going forward, and some of the reasons that it's better than the existing V2 framework and in the V1 framework itself. So one thing we're trying to do is to move all of our existing V2 APIs, the ones that are not on JAX-RS, over to use JAX-RS. And that way we'll get more of the benefits of kind of the open API tooling that we want to put in place. We'll kind of see improved maintenance burden because we won't have to maintain this additional framework that the V2 APIs are, some of them using today. We just want to kind of standardize on a single framework. And JAX-RS is kind of the winner there in a lot of people's eyes. So those are kind of the three big pieces. We're trying to polish up the APIs. We're trying to kind of align them on the JAX-RS framework. And we're trying to plug gaps that the V2 API has today so that it can be kind of feature complete in terms of having parity with what V1 offers. There's a lot else that's going to be needed to actually go in and deprecate the V1 API and get rid of it ultimately, kind of in the longer run. So there's an umbrella ticket for those. These are kind of things like, Solr uses its own APIs to talk to different Solr nodes internally, or the admin UI is a client that uses Solr's APIs. And these things need updated to use the newer V2 stuff. Right now, they just use the V1 APIs. So there's a lot of other tickets kind of surrounding this, but these top three bullet points are really kind of the core pieces here. And that they've all been worked on pretty actively by Eric, myself, and others. And many of them have kind of new dev labels associated with them. So these are all things that, if any of them grabbed your interest, you can go to right now, and it might be a great starting place for you guys. So this is one of my last slides. I have a few additional references. So again, I've mentioned this spreadsheet a couple times. There's a link to it here, and you'll be able to use that when I publish these slides or when I follow up on the mailing list. There's also kind of a step-by-step guide to writing a JAX-RS API. That's actually what we're going to cover in our example in a few minutes, but if you prefer it kind of in a written format, there's a write-up in Jira that this link will take you to. And kind of accompanying that, there's an example PR. And you can look at each step in this step-by-step guide is a single commit in this PR. So you can look at the diff separately to see in concrete terms, kind of what does this step mean? What do I have to do here? The last thing that's worth mentioning is that just this week, there's been put out a Solr improvement proposal, which is kind of a rarer process that the Solr community uses to handle kind of large overarching changes to the code base that are spread across many JIRAs, where it's just helpful to get kind of a high level overview. And so this was just put out this week, and it kind of describes some of this work that's going on with the V2 APIs. So again, if you prefer kind of a written format to listen to me ramble, that SIP is going to be like a place to go, Sorry, let me just take a drink here. So this is one of my last slides. I was going to switch over to kind of an extended example at this point. But I just wanted to mention, if we lose anybody on the example or if I run over and people have to drop, I wanted to make sure people got this. In terms of where we're going to go next for contributor workshops, one of the first things we're thinking of doing is setting up office hours, and I think we're hoping to have those next week. So keep an eye on the mailing list or Slack or wherever you heard about this from. We'll probably continue to use those same channels. And in addition to that, we're looking for ideas for new contributor workshops. Eric mentioned sending out a poll to see if there's anything people would like more information on. And we've already had some kind of cool ideas. Somebody suggested how to do testing in Solr, which is, there's a lot to be said on that. So yeah, so we might have some additional workshops, but the first thing coming is probably office hours. So keep an eye out for that. Cool. So that's all I had in terms of slides and talking before we kind of just jump into this example. Does anybody have questions on any of the stuff that we've talked about before I start going back to the IDE here?
So Jason, I have one quick question.
Yep.
So I'm just wondering if there is any doc or something which tells us the workflow, like once you, like, so for example, if you take up any ticket, you come up with some code, test it locally. How do I commit the code? Like what happens after you put the PR?
So, well, didn't we cover some of that in the video, the last video?
Okay,
Yeah,
I didn't
were
go through the
you
first
able to
one.
catch the first contributor workshop? We
No,
touched
I
on that
missed
some
the
there.
first one. Okay, got
Okay.
it.
Yeah,
So
yeah.
definitely check that one out. Maybe
Sure.
we should post some more documentation on kind of what that process is, but that's definitely what I would look at in the other one. So.
Okay, sounds good. Thanks a lot.
Yeah, no problem. Anybody else have anything?
I have one quick question. Jason, you showed the main code of the APIs V1 and V2. I was curious about the testability, like how the tests change in writing the two. I don't know if you plan to cover that in the working example, or if you can spend a few minutes on discussing this.
It's a good question, and kind of as we convert more of these V2 APIs, it's something we're still working through. So most of Solr's tests use Solr J, which is currently using the V1 API. So if you write a traditional Solr test, it's going to test kind of the V1 API. So kind of the normal way of doing tests in Solr doesn't translate super well to the V2 API. There's a couple ways we still manage to test this. There are our unit tests that, I mentioned an example PR here. So that has unit tests that you can look at to get an example. There's kind of a test base, a test framework. I'm not sure quite what to call it, but there's some helpers that Jersey makes available for testing Jersey APIs. So we use a mix of those and unit tests. But the key piece is that for various reasons, testing being one of them, as we go through this example, you'll see that I am changing. Not only are we introducing a new V2 endpoint to kind of fill a gap, but we're restructuring the V1 code to use this new V2 endpoint that we've just added. And that way, so when your normal Solr tests run, these tests that already exist for V1, they're kind of implicitly testing V2 as well. So there's kind of a layered testing strategy there. It's not perfect, but it's kind of what we've had figured out so far. Definitely open to feedback there as well too. Does that answer your question?
Oh yeah, thank you so much.
Yep. Okay. Anything else before we go to the example? All right. I will mention before I jump into this that I ran long this morning, and so I'm trying to be considerate of everybody's time. So I'll try to go through it as quickly as I can, but I'm happy to cover it in more detail if people ping me afterwards or want to show up to office hours next week or whatever. So hopefully everybody can get a chance to see this in as much detail as they'd like. Okay. So we talked before about how the V2 API has gaps. There's functionality that's not exposed in V2 that is there in V1. And we have kind of a parent ticket for this, and it has a number of subtasks. And I picked this one somewhat arbitrarily to look at. This covers APIs for Solr functionality called create snapshot, list snapshot, and delete snapshot. So just to give a little bit of background, snapshots in Solr are kind of this backup adjacent functionality where you're not doing a backup that sends data to some other server so that you can recover from a disaster or something like that. But a snapshot is similar because it kind of checkpoints your index locally. It stores some files locally to checkpoint it. And that won't help you survive a disk failure or anything like that, but it will help you kind of run experiments or something similar. Say you want to change your analyzers that you use to index data, and then if it doesn't work out, you want to go back to your old thing without re-indexing. Well, snapshots are kind of a great way to do that. You can create a snapshot, and then if your changes don't work out, you can kind of just revert to it later on. So there's several APIs that are missing, and for this one, I wanted to focus specifically on list snapshot. Give me just a second. Okay. So can everybody see the text on this? Is this okay? Okay, so I just wanted to give people a little background on how to use kind of the snapshot functionality that exists today and to look at the response of this API. So we know kind of, we have a sense for what we're looking at here. So you start out by creating a collection. This is kind of the bin Solr script that lets you do that. And then you'd index some documents. This is just kind of an example indexing command. And when you're ready, you would create a snapshot. And so this is the admin collections request handler. So it's called collections handler. We looked at it a little bit earlier, and it uses one of these actions called create snapshot. And you say what collection you want to snapshot, and you give it a name, checkpoint 1. So you might do a whole bunch of things. You might re-index data, and you might decide later that you want to kind of check what snapshots you'd taken previously. So again, the parameter here is action equals list snapshots and collection equals foo, and you get kind of a response that looks like this. You can see that we get this snapshots key, and under there is a list of different snapshots. And here we have our one thing that's named checkpoint 1. And then there's some metadata about that. And then since this is a collection snapshot, that kind of triggers snapshots down at the individual core level too. So it gives us metadata about the snapshot for each core. And this collection only had one core when I took a snapshot. So there's only one thing in this list. But you can see the name of the core and the place it lives on disk and the list of files involved in the snapshot and those sorts of things. So yeah, that's kind of the snapshot functionality at a high level. That'll be, we'll come back to that a couple times as we're going through. Okay. So we've looked at kind of what the code looked like, or what the functionality looks like from a user's perspective. Let's go take a look at the code. Okay, so this is the handle request body. This is kind of the main entry point for our V1 API. And this is in collections handler, which we talked about earlier. This is that kind of monster collections handler that has like 20 or 30 APIs kind of built into here. And if you look at what it's doing, it looks for this one kind of action parameter that we've seen in our API calls. And what we do is we kind of get a collection action and then a collection operation that are all keyed off of that string value that we just pulled out. And we do some things like we throw an error if it didn't exist or whatever. There's also a little bit of kind of MDC log tracing set up here. But really the root of things is this collection operation, which then gets invoked, and that's kind of where the real kind of magic happens. So we're interested in list snapshot, and you can see kind of what the API is actually doing here. This is the code that's actually going to get run once you figure out what collection operation you're talking about. So if you look at the request, one thing that kind of should jump out is, again, the request is where all of your inputs come from. And the only thing we're ever doing with it is we're pulling out this one collection property. So it's pretty easy to see that there's only one parameter to this API, and it's this string called collection. And so we have this whole chunk here that takes this collection and it resolves it if it's an alias. Solr has aliases, so you can kind of give pseudonames to point to different collections and then kind of change those as you will. So we find the whole gist of this is to find the real underlying collection that this string value is pointing to, and then here we're making sure that it exists. And that's really what all of this does. Down here, we get a Zookeeper client. That's so presumably something about these snapshots lives up in Zookeeper. And then we kind of call, this is really the heart of this functionality is snapshot manager.list snapshots. And I will say, without any shame, that I have no idea how this works. This is a total black box to me. But I know that there's only really one input that we need, and that's the name of the collection that we want to operate on. And you know, that's enough to write a V2 API, as long as you know kind of the cosmetics and the interface, and you know what code you need, then you can kind of write a V2 API. So this last part of the code here, it looks like this list snapshots method returns this collection of metadata, and then we iterate over it and we're adding it to something. And if you look at this something, this is our snapshots. This is a named list. We talked about this before. This is kind of Solr's abstraction for what response bodies look like. We build out this named list, and that's kind of how we return a response to the user. And so essentially we're just kind of iterating over all our snapshots. We're converting them to a named list and kind of aggregating them and returning that as the response. Okay, so we've looked at the endpoint from a user perspective. We looked at kind of where the code lives. There's just one last place we have to go, and then we're ready to start actually writing some code. We'll go back to our spreadsheet, and we can find our list collection snapshots endpoint. This is the thing that we want to create a new V2 endpoint for. And I know that somebody's already proposed what this should look like, and I can go to this V2 example proposed section and find it. If you didn't know where to find this, you can come in and you can Control F to search for a list snapshot, and then take you right here, pretty much. So we want it to be an HTTP GET request, and we want it to have this path where it has API collections, the name of the collection, and then just snapshots. And that's it. Okay, so I think now we have everything we need to actually get started. Any questions before we start writing some code?
It's great.
Sorry, Eric.
Yeah, and we should share this. This might be some of those directions that we were looking for as well, right? This is nicely done.
What, this right up here?
Yeah.
Yeah. So I mentioned this, and this is linked to kind of in the references slide that we were looking at earlier. But this is kind of a step-by-step guide just through how you create a new JAX-RS API from scratch. And so there's 7 steps here. Most of them are pretty straightforward. 6 is more involved. But you know, we'll kind of just take them as they come. So let's see. So the first step is to create a class that's going to hold our new API. You know, pretty straightforward. There's more information here on like, hey, you might want to use this base class while you're doing this, or here's how you create a constructor for this. But let's get the code in there and then we can talk about it. So I'll go over to my IDE. The Zoom screen share toolbar like blocks the top window of my IDE, so I'm flying slightly blind here. Okay, so I just pulled up a random other JAX-RS API because I wanted to point out that a lot of these APIs, kind of the convention for these, is that they live in the handler admin API package. I guess specifically that's org Apache Solr handler admin API. So let's create our new one here. So I'll call it list collection snapshots API, which is a reasonable name. The only thing I'll say about it is I added collection because there's also a similar API at the core level, and you just want to be able to distinguish between those two. So that creates our API. Let me just copy some canned code in here, and then we can talk about it. Okay. Let me deal with my import errors, which is always fun. Okay. So there's only two real deviations here from the kind of the IDE generated template. The first is that we're extending this base class called admin API base. And this is something that's kind of sprung up and that's relatively specific to stuff that comes out of collections handler, APIs that are collections handler related. It turns out that these share a lot of kind of common functionality, like every collections handler API starts by checking to make sure that we're running in Solr Cloud mode, because there's no such thing as collections if you're not running in Solr Cloud mode. And there's a couple other, there's some functionality to set up kind of the MDC logging here based on your collection, a few different things. So because we are kind of working on something that's based off of collections handler, we're going to extend this base class. The next thing I want to talk about here is this constructor. So obviously the name is the name, and we take a handful of arguments here. So one thing to say about these arguments is, unlike request handlers, which live for a long period, they serve many requests. The API classes are instantiated by Jersey or by JaxRS kind of on a per request basis. At least that's the default behavior that we use in a lot of places. And so you can set up your API classes to have certain information kind of injected that's specific to the request, or even some things that are just useful to have, like a core container. And so Jersey is able to find these classes and kind of inject them through its own dependency injection mechanism, which is kind of its own topic. But if you're not familiar with dependency injection, essentially you kind of specify a certain annotation, and then by hook or by crook, by magic, Jersey is able to find these objects and put them when it tries to instantiate this class for you. So these three, whenever I'm creating a new API and I'm not sure what I'm going to need, these are kind of the three that I start out with. It gives you your Solr query request and your Solr query response. We don't use these to actually get parameters or to set up anything in the response, but they are nice. The Solr query response lets you set headers, and that there's some kind of miscellaneous things that these are good for. And the core container is just kind of a generally useful object to have access to in Solr. There's a lot of stuff that kind of hangs off of core container. So this is kind of the root class. If you're creating any kind of new API, it's going to look very much like this. You're probably going to want to inject these three objects. Yeah, any questions there?
I just have one quick question.
Yep.
So for example, if you want to, this is a get collection snapshot. And if, say, for example, if I'm updating the snapshot, do I really need to create a new class? I'm asking because in Spring Boot, you have one resource class and you had all the updates to that CRUD operations in a single class.
Yeah, so that's kind of a convention.
Okay. So we have to create a new class for every request type.
Yeah, I mean, I like to put all the CRUD operations in one place. I think that makes sense. But I've gotten feedback in review that other people don't like that. They'd like things to be as small as possible. So it really depends who's reviewing stuff for you. Yeah, I think it's fine either way. You can kind of have several APIs in the same place, or separate them out individually. It doesn't really matter.
Hey Jason, sorry, I had a question.
Yep.
Is there basically a comparison framework, test framework, so you can specify like v1 API call, v2 API call, and it checks that the results are the same?
So generally, we write some. The short answer is no.
Okay.
it'll be a little clearer at the end of this example, kind of how we do some testing around that. And I can pull up tests that do similar testing. But the short answer is there's nothing built in for that. Generally, that's kind of a root unit test that you'd have to write yourself.
Okay, thank you.
Yep. Okay. All right. So this is step one. We have our API class. That was pretty easy. Step two is going to be even easier because step two is about creating a request body, a Java class to represent your request body. And if you guys remember, we're trying to create a GET request. And there's only one parameter, which is already in the path. So we don't need a request body. So step two is also done. So that's great. Step three is where things are going to get a little complex. Here, we're supposed to create a Java class that represents the response that gets returned to users. Let's see if I can share this here. Oh. Sorry, just a second. Okay. So to drag my terminal back in here. So we looked a little bit at what this response looks like. So we have a sense for what it looks like, and we can kind of create kind of a Java object based off of these that has, say, properties for name and status and creation date. So let me create those and copy those into the IDE, and then we can kind of talk about some of the interesting pieces there. Just a second. Sorry, I'm window juggling here. Okay. We'll put them right below our constructor for now. Let's handle all of these imports. Yay. Okay. One last import. Okay. So if you look at this, if you look at kind of the write up here, it mentions this Jackson Reflect Map Writer interface. And that is kind of I guess an empty interface that just kind of marks that these are things annotated with JSON property annotations, which we have some reflection code, which is able to, well, rather Jersey has some reflection code so that it's able to kind of marshal our response and send it back to users as JSON or XML or whatever, based on kind of these annotations that we put on here. So this attaching this interface, even though there's nothing you have to implement, but attaching this interface is kind of useful and required from a Jersey perspective. These annotations, I imagine most people here are probably familiar with Jackson, but this is just, essentially this just says the name of the property when this gets serialized out. And usually it matches the variable name and it's redundant, but that's fine. So we have our kind of root response here, and it has a single property to represent the snapshots, and then it takes a list of things, right? And this kind of lines up. It should line up pretty well with the response we already looked at. So here we have a single checkpoint named checkpoint 1, and that checkpoint itself has properties for name and status and creation date. And then in turn, you can see here we have a map of the string is the replica name or the core name, and then we have metadata about the replica. So if I can scroll down, yeah, look at that. So we have the core and the index directory path. So all this stuff is kind of taken from just kind of an example response. That's probably the easiest way to at least initially kind of bootstrap these response objects. It's always useful though, just because a given response might not show you everything that could be in any response for an API. It's always useful to go to the actual code and see kind of what the different possibilities are, just to be thorough. So here we're getting this list snapshot API, or this list snapshot metadata, and it's all in this collection. This is where kind of everything in the response comes from. So the thing to look at would be to go into this object here and see kind of what properties it has. And we're calling this toNamedList method on it. So we can go look at that and see kind of what properties end up in this named list conversion, just to make sure we're not missing anything in our response bodies. We just kind of want to be thorough there. Okay. Cool. Let's go back. So now we're at our list collection snapshots API. Oh, yes. So it's kind of weird if you look at the V1 code. You know, the V1 code already has an object that's kind of like custom built to hold all the metadata about a snapshot. Why would we write our own? Why would we write our own objects just to kind of be a repackaging of that same metadata? It's kind of redundant. And the answer to that is, this is just an example. This isn't how I would actually do it for real. If I was pushing up this PR for real, I'd probably add JSON property annotations to this class so that we can reuse it rather than creating kind of a new class just for our response body. So just kind of a note on the redundancy that might jump out at you guys as we're looking at this. Okay, so let's go back to list collection snapshots API. Okay, so we have our response body classes. That should be that step. So we've done 1, we've done 2, we've done 3. Now we need an actual method here to represent our API. And again, this should be using kind of these objects that we created in steps 2 and 3. So this is should be relatively simple. Okay, so in our case, this method is going to look just like this. It's a public method. It returns this kind of API response class that we just created. The name can be whatever you would like, but I chose list snapshots. And we know our API takes one parameter called collection name. So I've kind of created that here. So that's the step, pretty straightforward. This next step, step 5, is where we actually kind of add the JAX RS annotations that we kind of looked at in some of our other API examples. We're going to be putting it in at path annotation and at get annotation, because again, this is a get request. So let's copy that code in, and then we'll see kind of what questions there are. Again, at this step, this API won't actually do anything because it's still just returning null, right? But at least the way kind of I've broken the steps down, I thought this was helpful. But you can kind of, once you've done 1 or 2 of these and you see the pattern, feel free to do this in any kind of order that makes sense to you. Okay. So looking first at the method, we have the @get annotation. We have @produces, which is basically represents the format that Solr can return back with. It can return back with JSON or XML or kind of this binary response format that Solr supports. This permission name annotation is kind of an integration with Solr's authorization framework. You can kind of find the right value of this by going to collections handler and seeing what it uses, because it has kind of a similar integration there. And then the only other thing to comment on here is that we've added this path param annotation to our collection name variable. That's kind of the only input for this API. So you can look at this collection name in that kind of that string value, your path annotation in squiggly brackets. That's kind of how you connect this particular piece of your path to your actual input method here. Okay. So those are the annotations, and I think that's that. So we are on to step 6, which I mentioned earlier is probably the more involved of the sections, because this is where you're actually taking the logic that makes this API work, and you're kind of converting it over to the V2 code. In a lot of ways, this can just be kind of a copy paste operation. There's a lot of stuff that should just be able to go over as is. Particularly if you look at kind of this stuff here, where we're sanity checking our collection, a lot of this stuff is going to be able to go over just as is. We don't have this H variable say, but that's a pretty easy edit there. So it's a relatively simple transfer. Where things will get a little different is after we call this list snapshots API, this list snapshots method, the way that we kind of package this into a response is going to be different, obviously, because the V1 response is a very different format than the V2 response, just in terms of being very loosely typed in this named list versus very strongly typed in these kind of Java objects that we've written up. Yeah, so I kind of have this code canned, so let me copy it in and then we'll talk about it a little bit. Oh, imports.
So many imports.
Yeah. And then of course you get something that throws an exception, and that needs to be added to the method signature. So those sorts of things are expected. This is something that I keep neglecting to add to my little text file of code snippets here. Okay. So this is what the body of our API is going to look like. We'll kind of go through it section by section here. This is mostly boilerplate for all of our kind of admin API base subclasses, just based on, oh, come on. Just based on things that are kind of happening here before any kind of collection operation gets invoked. We're doing some logging setup, we're sanity checking that we're kind of running in a Solr cloud environment. List collection. Yeah, so that's what kind of this initial chunk of things is doing. And if you're working on a collections API, there's plenty of examples you can go to. You can see that add replica property has almost the exact same code. So from there, we have a chunk that should look very familiar from what the V1 code was. We're getting our collection name, we're resolving it to an alias, we're sanity checking that it actually exists and that it's a real collection. And then we're calling kind of this black box Solr snapshot manager.list snapshots. And where our code really diverges from the V1 code is really kind of where we start to put it into a kind of these Java response objects. The V1 code had that toNamed list method, and it was just shoving everything in a map. Whereas we are kind of setting individual properties based on the value of these kind of individual collection snapshot metadata things. Again, it kind of works out a little ugly in this example, just because I wanted to have kind of a response body that was strongly typed here that we created from scratch. But if I was doing this for real, I would have just annotated this class with JSON property, and then we wouldn't need to do all of this kind of conversion here. So it wouldn't look nearly so ugly in practice. Fix my indenting there. Okay, so now we have a V2 API, the class exists, the method exists and has actual logic that will do actual stuff. but there's still one piece that we have to do for this step. And that's go back to our V1 code and kind of reduce some of the duplication there. Because a lot of this stuff, this is specific to V2, say, but all of this stuff is kind of duplicate for what's over there in V1. So we will go back to our collections handler. We'll go to list snapshots. Okay. And one thing that we can do now that we have all of this logic kind of encapsulated in a single class, we can really just delete all of this and then instantiate our class and then kind of reformat the response in a certain way. So what this looks like, we still have this line that gets our collection, the parameter that was passed into us. But now all the V1 code needs to do is it will instantiate our API class that we've just kind of worked hard on. It'll call this particular method. It'll pass the API or the collection name in, sorry. And then all of this results in a response. And we talked earlier about this Jackson Reflect Map Writer interface. And one of the reasons we stick to that interface is because we have this utility that can use reflection to look at all of those annotations, those JSON property annotations we put on things, and it can squash it down into the Solr query response kind of loosely typed map format that the V1 code expects. So here we're kind of reusing all of our API code, and all we have to do is kind of wrap it in this one method call here. And then our V1 code path is good. There's a question earlier about testing. How do we kind of test our APIs? And I mentioned that the V1 code is re-implemented to kind of rely on the V2 code. So there's some implicit testing here. And this is kind of the thing I was alluding to, is that if you're doing these kind of in the same pattern, your tests that are testing V1 will also kind of implicitly test V2. There's a bit of a gap there, obviously, but it's better than nothing. Cool. So that's step 6.
We have, sorry, do we have for AB1, the ABI version 1, we have a test unit for them? Or we sometimes might need to write the test unit for that one also before refactoring?
I think writing a unit test before you can do that refactor would be an awesome idea. The problem that you'll run into is that just the way the V1 code is structured, it's very hard to unit test. You know, like we have this very involved enum that has like a function is one of the things that is part of the enum class, and kind of invoking this in a unit test kind of manner is difficult. It's also difficult to kind of fake up requests and response and mock a core container in unit tests. I love to see unit tests everywhere we can get them. A lot of people have written them off just because the way the code is structured makes it very painful. But I would encourage you that if you're willing, definitely give it a shot. But in terms of existing unit tests, there's not much. It's a lot of integration tests.
Yeah. So I think there is also at least integration test, right? So if you know there is no unit testing, there is integration test that tests the API itself. So there is why to know I messed up something if something is actually broken while you do refactoring. Yep,
that's the goal. A large percentage, probably like 80% of Solr's tests, I'd say, are integration tests. And that's both good and bad in different ways. But there should almost always there's tests for the API you're going to change. So there's at least some coverage to kind of be a safety net for you as you make these changes to make sure that you don't break V1. Cool. Any other questions before we get to this last step here? Awesome. Okay. So the last step is, again, pretty simple. So we've created this new API class, but nothing kind of registers it with Solr by default. We can set Jersey up to do kind of class path scanning and detect these things, but for startup cost reasons and some other security things, we've opted not to do kind of class path scanning. So instead, all of our V2I APIs are kind of registered in connection with a request handler. When Solr starts up or when Solr creates a new core, it knows what request handlers it has, and it'll create each of those, and then it'll ask them, what V2 APIs do you know about? And then it'll go and register those. So when you're creating a new V2 API, you can go to the request handler that it's kind of affiliated with. And you can go to this get Jersey resources method. And this is kind of, it just returns like a Java list of all of the kind of class references for your Jersey APIs. If you're using the legacy kind of V2 framework, there's a separate method for that. But regardless of the V2 framework you use, you want to register your API in one of these two methods. And that's it. That's the last of our 7 steps. We've kind of created our new API. If you were doing this for real, you would probably go and update the reference guide to include kind of this new cool endpoint that you just added to the V2 API. You would add tests, as people have asked different questions about that. That's probably something we should dig more into in office hours or another workshop or something. But there's definitely some questions there, but you'd want to write tests for your PR. But that's essentially it. You've kind of written an API and you can rebuild Solr. Let me see if I can come over here. I'm not actually going to wait through this, but you can run Gradle assemble to rebuild Solr, and you can start your Solr and it will have your API. You can hit it. It's very rewarding to do that. But so that's kind of the extent of the example that I wanted to walk through. Does anybody have any questions before I stop screen sharing here?
Will there be any performance benefit from this change?
So we're still kind of doing performance testing on the V2 framework. The expectation is that it's not a performance improvement. It's primarily kind of a usability and a maintenance improvement. But who knows? It's conceivable that is kind of a framework that's actually written by API framework developers. There may be some speed up here, or there could be a slight slowdown, but the verdict's still out on that.
And how do you, for example, create the URL for this version 2 API? Are you following some kind of convention, or how do you create the URL and the information that you pass on the body of the call?
Is your question kind of like, how did we come up with these proposed changes? Like what kind of?
Yeah.
Yeah. So generally when I came up with these, my number one goal was consistency of APIs within Solr. But as you might be able to tell looking at the APIs, I do have a background in kind of REST APIs where you use the HTTP verb in kind of a semantic sense, and you use the path to indicate the particular resource you're talking about. And the conceptual plan of the API is based around these kind of noun resources. So as we were coming up with this proposal, I think kind of our thoughts were mostly on kind of REST as a model. But there's a lot of places where Solr doesn't fit that model very well. And so it's not pure REST by any stretch. But yeah, if there's any kind of model, I'd say it's mostly RESTful.
Yeah, I mean,
does that answer your question?
Yeah.
Cool.
Yeah, I would love to see it a lot closer to REST, like unless we have a real reason not to follow that standard, just because that's what so many other people know. Yeah,
it kind of the thing that's tough to do is that Solr has so much functionality where it exposes a lot of like really intricate like admin operations that are necessary for users to have to modify performance in these different things like merging indexes, deleting nodes. These are all kind of like scaling things. they don't really fit very well into kind of a REST model. There's a lot of these kind of verb-based commands. And I struggled for a while. Some people that I asked to help me review this struggled for a while to come up with some way to better kind of fit these into the REST model. Yeah, and it was tough. That was definitely our goal, but it was tough, and I don't know how well we succeeded, but we did the best we could. Well,
Yeah.
that's all I had. Does anybody have any other questions before we get going?
So one question, Jason. So what are the next steps? Like we can directly go ahead and pick the Jiras and start the work, or
Yeah, sure. Let me share my screen again real quick. So I had a link for several of these things in my slides, but I mean, so even if you just want to jot down a quick Jira number, if you wanted to go and do one of these, you can go to Solr 15737. You can go grab any of these subtasks and then just kind of comment on the Jira and say, well, not this one because somebody else already commented on it, but you can go to say, yeah, this one, and say, hey, I'm interested in doing this.
got it.
Has anybody else started on it? And then almost surely nobody will say anything, or somebody will say, no, it's yours. And then you can start working on your PR and push up a PR when you're ready.
Got it. Thanks, Jason.
Yep.
And I guess from the demo they just walk us through, it doesn't seem to be too much effort, right? I mean, from the look of it, but like if I have to plan something, it seems like a 2 or 3 hours time as a maximum to get one of these API and change them by the log of it and from what we have seen today. So it could be up and down, but I'm just thinking roughly, right?
Yeah, I'd say that's accurate for most APIs. There are some where even just the step where, say, figuring out what all the inputs are and what kind of variations the response format might have. Even doing that involves a lot of digging. But for most of these APIs, it's 2 to 3 hours sounds pretty correct.
Yeah, great. Yeah, you could sit with the kids and them, and then they watch something and you watch something and then you just finish
you
it.
put on a Disney movie and you're good to go.
Yeah.
That kind of thing.
Okay, great.
I think where sometimes you run into things is when you find other shortcomings or places. This is where my PRs end up being way too big, is I'll start pulling and be like, oh, I want to fix that and I want to fix that. And it's definitely much better to have lots of small PRs, not one big one, because it just makes the review side so much harder.
Yep. Yeah.
And it's about the focus, right? You want to scope whatever you're doing, so you are managing it in a small time and also making sure you're not breaking many things. Yeah.
Yep. Totally.
Cool. Well, thanks everybody for coming. I really appreciate the attention and the questions. It's awesome. It's great. I hope it was helpful for you folks. And again, keep an eye out for either a survey for more topics we might cover, or kind of an announcement about office hours if you're interested sometime next week.